We're looking at Unit 6, Lesson 5, and this lesson had to do with special right triangles. And so the first thing I want to do is I want to talk about the special right triangles that we talked about in class. And so the first one was a 45, 45, 90. And if I have a 45, 45, 90, then I know that two of my sides need to be the same. In other words, it needs to be an isosceles right triangle. And so each of these angles would be 45. And, oops, 45. That's a 45, sorry. So if it's a 45, 45, 90, then we say this side is 1, this side is 1, and this side is the square root of 2. Because 1 squared plus 1 squared equals the square root of 2. And so my next one was 30, 60, 90. And so we have one side longer than the other. And my right angle is here. This would be 30. And this would be 60. And if that's the case, then 1 goes here, 2 goes here, and this is the square root of 3. Okay, so I use these triangles that would be similar to the triangles that we're looking at today. So if I look at number 1, this triangle should be similar to the 45, 45, 90 that I drew over here. And so let's just call this X and this Y. So if I'm looking for X, I could say 4 is to 1 as X is to 1, and so obviously that would just be 4. If I'm looking for Y, I could say 4 is to 1 as Y is to radical 2, 4 is to 1 as Y is to radical 2, and so when I cross multiply, I get Y equals 4 radical 2. Or really, you're just multiplying everything by 4 in this case. So 4 radical 2. Okay? And number 2, this one would be similar to this triangle down here. And so this is my hypotenuse, this is my hypotenuse. If I want to think of this as a scale factor, this 10 is 5 times more than the 2. And so the side across from the 30 is going to be 5 times more than 1. Or 5 times more than that is just 5. This side over here across from the 60, so that side is going to be 5 times more than radical 3, or 5 radical 3. Okay? This one is another isosceles right triangle, so I know these angles must be 45 and 45. Okay, this is where a proportion would come in handy, because I don't know the scale factor between 17 and radical 2. So if I call this X, I would say 17 is to radical 2 as X is to 1. And so 1 is what that length is there. So really, you don't have to put this over 1. If I cross multiply, I just get 17 radical 2. So X is 17 radical 2, but we talked about in the last unit, we don't like to leave that radical 2 in the denominator. So we want to rationalize that denominator. So to rationalize the denominator, we multiplied the top and the bottom by radical 2. And so on the top, we would have 17 times radical 2 is 17 radical 2. And on the bottom, we would have radical 2 times radical 2, which is just 2. This is going to be my length for both of the congruent sides over here. So 17 radical 2 over 2 for that one, and this one. That's my solution. Okay, and then the last one, number 4, this 5 would correspond to this radical 3 over here. And so you see they're both across from the 60. These should be similar triangles. And so you would say 5 is to radical 3. 5 is to radical 3 as, let's call this X, as X is to the hypotenuse 2. Cross multiply, and you get 10 equals radical 3x, and you divide by radical 3, and divide by radical 3. Okay, so again, we end up with something that doesn't have a rationalized denominator. There's an irrational number there, so I'm going to leave you to rationalizing that, and I'm just going to take a look and try to find this side. So y would be 5 is to radical 3, 5 is to radical 3, as y is to 1. And so you just get 5 over radical 3, which I also want you to rationalize that denominator. Okay, so these two, this and this, need to be rationalized before you turn this in tomorrow. Rationalize and rationalize.